Hi guys, today is our fourth session of renal physiology series. So today we are going to talk about renal tubular reabsorption and secretion. So in this topic we are going to talk about first about the renal tubular reabsorption and secretion. Then we are going to talk about the tubular transport mechanism, the secondary active mechanisms and transport limits. First, our topic is renal tubular reabsorption and secretion. So, as we talked about on our previous sessions, the glomerular filtrate flows through proximal tubule, then the loop of Henle, distal tubule, collecting tubule and collecting duct. So, when the filtrate flows through this pathway, there are two processes mainly happens. They are reabsorption and secretion. So, in reabsorption, substance move from tubule to the blood. In secretion, substance move from blood to the tubule. So, the final urine output is composed of filtration. It's minus from the reabsorption and secretion is added to the filtration. Okay. So, what are the roles of this? When we talk about reabsorption and secretion, reabsorption is more significant than secretion for most substances. Okay, and the secretions is important for like potassium, hydrogen and a few drugs or waste products because they have to excrete by secretion. So, the tubular reabsorption, this is quantitatively large and highly selective. When we talk about examples like glucose and amino acids, they are completely reabsorbed at proximal convoluted tubule. And like sodium ions, chloride ions, bicarbonate ions, they are highly reabsorbed but regulated. Not complete reabsorption happens, okay? And the poorly reabsorbed one are urea, creatine. Why don't we completely or most amount don't get reabsorbed? Because we have to excrete them in urine. Okay. This is the filtration example. I think in renal physiology third series we talk more about the how we calculate things and how do we get these rates. Okay. When the normally all things reabsorb like protein, not protein, glucose and amino acids, there are zero excretion of these products like glucose and amino acids. They are not in urine. Okay, in a normal person. So, what is the importance of this coordination? When there is a small change in reabsorption or filtration, it can cause a large change in excretion. Example, when there is a reduction of reabsorption by 10%, urine amount can increase from 1.5 to 19 liters per day. It's a huge amount. And so that filtration and reabsorption are tightly coordinated. When we talk about the mechanism of reabsorption, it's a two-step process. At tubular epithelium, reabsorption happens at interstitial fluid, and interstitial fluid it happens at then the interface is peritubular capillaries. At that place, there's bulk flow happens. And when we talk about the pathways are transcellular and paracellular. Okay. In transcellular pathway, the solutes like water and solutes are transported through cell membrane themselves. So it is transcellular. And in paracellular routes, they are transported through the space between the cell junctions. Okay. I think in this picture you can see it. So there is two-step process. In this picture you can see the tubular epithelium and interstitial fluid. Okay. And the paracellular part and the transcellular part. Paracellular part is between the cell membrane themselves, and the paracellular one is within the spaces, and the transcellular one is between the cell membranes. Okay. So passive and active transport. What is active transport? In active transport, when we have to move a solid against an electrochemical gradient, and it requires energy. It requires energy derived from metabolism, like ATP. Okay. In active transport, there are primary active transport and secondary active transport. In primary active transport, the transport is directly related to energy source. Okay, as active transport need energy source. In secondary active transport, the transport is indirectly related to an energy source. So that is called secondary active transport. In passive transport, there is no energy expenditure. So it's passive. So examples are osmosis, diffusion. Okay. So the sodium reabsorption. It is usually driven by sodium potassium ATPase pump. Okay, it is in the basolateral side. So when we talk about the steps, first sodium ions diffuses across luminal membrane according to the electrochemical gradient, and after that they are actively pumped across basolateral membrane. And the sodium plus water, they combine, they can go with capillaries via bulk flow. And in this brush border, there is increased surface area for transport. And the glucose and amino acid reabsorption. So it transport via secondary active transport with sodium plus. As I told you, secondary active transport, the transport is indirectly coupled to an energy source. So the carriers are SGLT2 and SGLT1. SGLT2 receptors are in early proximal tubule, and they are 90% glucose reabsorbed by these SGLT2 only. So the SGLT1, they are in the late proximal tubule, and they only absorb 10% of the glucose. And when the glucose and amino acid reabsorb glucose and amino acid transport to the blood, the transport GLUT1 and GLUT2 helps. So in this first section summary, we talk about urinary excretion depends on filtration, reabsorption and secretion. And reabsorption is large, selective, and it's highly regulated. The key transport mechanism systems are sodium, potassium, ATPase pump. It's a primary active one. Primary active means it's directly coupled to an energy source. And the sodium glucose co-transporter, secondary active, is indirectly coupled to an energy source. And these are essential for maintaining fluid and electrolyte balance. Okay. So in this second section, we are going to talk about the tubular transport mechanisms. So secondary active transport, glucose. Previous slide also we talk about glucose reabsorption depends on sodium, potassium, ATPase. Depend on the primary active pump. So the sodium gradient downhill diffusion provides energy for this procedure, and glucose moves uphill with sodium plus. So as these glucose and sodium move in the same direction, and same mechanism is the symport, and it's in the luminal side. So glucose acts with basolateral side by facilitated diffusion to the blood. Okay. So this is why we call it is secondary active transport. So the active transport rate process is called active. If any steps involve primary or secondary active transport. Okay. If as example in luminal side there is sodium glucose co-transport, secondary active, and in base electrolyte side there is facilitated diffusion of glucose, and into capillaries they are going through passive bulk flow. So they in this sodium glucose transport mechanism there are 3 steps, but only 2 steps are passive and 1 step is active. So as in this mention, if any steps in not primary or secondary active transport, the process is called active. So the 1 step involves secondary active transport, so we call glucose transport mechanism all as an active transport. Okay. Secondary active secretions. Some substances secreted by sodium counter transport. So as an example, sodium H plus exchanger, which is at the proximal tubule. When the sodium entry into the cell, the H plus secrete into the tubular lumen. So this helps to maintain acid-base balance. So pinocyte is for protein reabsorption. These occurs mainly in proximal tubule. So the steps are when protein binds brush border, the endocytes vesicle, protein is endosized by the vesicle and the vesicle is digested, and when the vesicle is digested, amino acid released because it's in the vesicle. So amino acid reabsorbed to blood, and this process requires energy. So this is active transport. The transport maximum, TM concept. So the active transport has a limit. It is called TM. So the carrier proteins become saturated if tubular load. When it increases transport maximum, the carrier proteins get saturated. Example like when there is glucose, there is a transport maximum. If the transport maximum is not exceeded, there is no glucose in normally, like in normal person. But in diabetes mellitus, there is increased glucose levels and the transport maximum is exceeded. So there is presence of glucose in the urine. So glucose threshold was TM. Threshold about 200 milligram per 100 millimeter plasma glucose. Small glucose in urine happens. So this occurs before saturation threshold reached because nephron have a variable TM. As we talk in this side, there is a variable TM. Okay. In diabetes mellitus, the plasma glucose levels will increase and the filtered load will increase and it close glucose-urea. So substance without TM. So this rate depends on electrochemical gradient, membrane permeability, tubular fluid flow time. So the examples are sodium reabsorption in proximal tubule. So this is limited by the back leak through tight junctions. So when there is a faster flow, less time for reabsorption. Passive water reabsorption. This coupled mainly with sodium reabsorption. The mechanism is the osmosis. In proximal tubule, there is a high water permeability. So at proximal tubule, there is high rapid absorption. And the distal and collecting tubules, the water permeability depends on the hormone antidiuretic hormone. So the chloride and urea reabsorption. Chloride reabsorption. Chloride reabsorption follows sodium plus reabsorption in a electrical gradient. And also chloride reabsorption follows the water. Water follows the concentration gradient. And also it can use secondary active co-transport. Okay. In urea it is partially reabsorbed, about 50%. And it is facilitated by urea transport, which is located at the inner medullary collecting duct. And the remainder excreted as major nitrogenous waste. Creatinine handling. Creatinine is a large molecule and it's almost impermanent. And it is not reabsorbed. So we don't reabsorb creatinine because we have to excrete. It's a excreted product, and we have to excrete all creatinine through the urine. Okay, and so nearly 100% of filtered creatinine is excreted, and we can use as a useful marker of GFR. So in this section, we talk about the glucose, secondary active transport and its limited value, and the proteins, how they are get reabsorbed. It's reabsorbed by pinocytes, and the sodium gradient train transport in proximal tubule, how the water is get reabsorbed, osmosis, ADH regulate, how ADH regulated in distal and collecting tubules, and the chloride and urea, they are absorbed through passive reabsorption, and both chloride linked to sodium and water. And the most important point is creatinine not reabsorbed, and the 100% of creatinine is excreted. Okay, that brings us to our of the session. Okay, thank you.